So we are looking at, hopefully it doesn't cut out. My internet's a little bit wonky, so the videos have been cutting out a bit here and there. Okay, so today we're looking at the domain and range of a function. We did kind of look at it a few days ago. So it should be a bit of a review, but it is quite extensive in terms of the examples and the work that you're doing today. So it's a lot more practice for you guys. Yeah. So we have the domain, which is all the set of possible values of independent variables. So those are your x values. This is the input of our function machine, which is an odd way of saying that, but essentially the way that you would always write it is d is equal to bracket x is an element of real numbers. And then you would put the line there and you would list out, so you would do x is equal to blah, 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 and you would list out all the numbers that you have. If it's a butt ton of numbers, you would do it like x is greater equal than a number, for example. And we're going to do a lot of examples. Like there's a ton of examples to do with you guys. So hopefully it makes a lot of sense. The range is all the possible y values. So that, again, we would do the range is y is an element of real numbers, and you're always going to write it like that. And then you would list off the y numbers and close off your bracket. Okay. So just a reminder here, we have the enclosed elements of a set. So that's that funky little thing. It's taking me a long time to get to be able to do that bracket. So if you guys aren't able to do it, I'm not going to judge what it looks like. I've been there. It's always looked silly. A comma is to separate elements within the bracket. The R, so you can either do 2 lines like that. I don't even care if it's just a 1 R. It means the same thing. So it means real numbers. Apparently there are non-real numbers, just FYI. I means integers, so that's negative, positive, those numbers that we've seen before. And then your funky E like that is an element of. So that's just a little bit of vocab for you guys there. And we're going to start off with our examples. So I'm clearing this. So for example 1, so state the domain and range for each relation. So for our first example, we have a set of points, and it is going to get quite repetitive, unfortunately. So if you guys understand it after a bit, by all means, skip this video. So we want the domain for our set of points here. So no matter what, we're always going to start with x as an element of real numbers, our line. And then what you're going to do is you're going to list off the numbers, not repeating, but in order here. So you're going to say x is equal to -3, -2, -1. And that is your domain. You're going to do the same thing with your range, but it is your y value. So y is an element of real numbers. Y is equal to, we've got 2, 3, 0, and 6. So y is equal to 0, 2, 3, and 6. That's it. Okay. We're going to do the same thing with these points. I'm going to have to write on this graph. So domain x element of real numbers, x is equal to, and you're going to start your way this way. So from left to right. That way you put them into order. So we do have one that's -4, -2. So note that there's no point on the -3, so you don't include that one. -1, 0, 1, 2, 3. There is nothing on the 4, so don't put a 4, and 5. Again, it gets long. Range, now we're going to look at our y values that are included in our graph. So y is equal to, and we're going to start from the bottom and go up, that way they're in order. So we do have one at -1. We have one at 0, 1, 2, and 3. Okay. When we look at this one, and this is kind of going back a little bit to our grade 9 math. So that's a linear function. So on a graph that literally looks like something along those lines, and it just keeps going and going. So when we think about all the x points that it touches on the graph, it touches every single one of those points. It goes on forever up until the sky. So our domain would be just simply x is an element of real numbers, and you close that up and that's done. Same with r. So our range is our y points, and that keeps going on both sides. So that'll be the same thing. So y is an element of real numbers, and that is it. So it's really just it's just making sure that you understand what's on the graph and going from there. I very rarely will make you do something like this. It'll usually be parabolas. So I'll show you the parabolas when we get to that point. So I'm going to clear this. Okay, so we've got x squared y plus y squared is equal to 16. Now I know that you guys have never seen anything like this, I don't think, on a graph. So that is quite literally just a perfect circle. If I could draw a circle, it would be a perfect circle. And those points, your circle touches 4, 4, -4, and -4. So that's what it uses as its radius, is just the 4s, because you square root this last number. That's all it is with those kind of graphs. So knowing that, our domain, x is an element of real numbers, you put your line, and then our x has points everywhere between -4 to 4. So what you do is -4, like this. Okay, so that means that x is between -4 and 4. And your range is going to be the exact same thing, because if you look at your y-axis here, it's between the points 4 and -4. So y is an element. I doubt that I would ever ask you to do this on a test, because you guys aren't versed in those kind of graphs. Okay. Here, so you need to kind of graph this one out, at least I did. So your zeros are going to be 0 and 6. We do know that because it is in factored form, which means our axis of symmetry is at 3 here. So if we put 3 instead of x, it's going to tell us what our vertex is. Okay, so that is equal to -9. So our point down here is -9. And it's going to look something like this. I personally find looking at a graph a lot easier to determine the domain and range. I still to this day can't really look at a equation and know exactly what I'm doing. So our domain is x is a element of a real number, as long, no, that's all it is. Because this keeps going on and on, so it's going to touch every point on the x-axis. And then we've got our range. So our range is every number that is above this -9. So our parabola goes up. It's never going to touch like -10 or -11. It's never going to do anything with those guys. So y has to be, larger or equal to -9. Okay, so now if we look at example 2, so determine if the relation is a function by a table of values or a set of pairs. So keep in mind, when we looked at what a function was, for every x, there was only one y. So we can never, ever, ever have two x's. It's not a function in that case. Okay, so I'm going to clear this. That way we can go on to example 2. Okay, so is the following relation a function? And state the domain and range. Okay, so here we're looking to see if we have more than one x value, okay, that repeats itself. So here you see that 2 has repeated itself. So that means it's not a function. That means that there's 2 y values for that point. Okay, so not a function. You can write there are two y's for one x. Okay, our domain for this guy, again, like I said, it gets repetitive. Element of a real number, x is equal to, and you're going to list them off in order. So we've got 1, 2, 3, and 6. Our range is all of our y values. So y is an element of a real number. Y is -8, -6, 2, 6, and 7. I'm right. Yeah. Okay. Here you're looking at your x values. Does it ever repeat itself? It does not. So that way it is a function. So yes. Okay, and then our domain is element of a real number, x equals -1, 0, 1, and 2. Our range is y is an element of a real number, y is equal to 0, 1. Oh, you guys can kind of see Molson in the back there a bit, and 8. Okay, so I'm going to clear that, and we're going to look at an arrow diagram. So keep in mind, again, each x value has only one possible y. So when we're looking at our arrow diagram, I'm not going to write anything because I don't feel like erasing it again. So you just look. So this brings you to -6. This brings you to 7. That brings you to 4, and then -6. There's only one for each x, so that means that it is a function. Okay, when we're looking at graphs now, so you're gonna do what's called a vertical line test. So what you do with these guys, with the graphs, is you do invisible lines that go along like this, and you just check to make sure that there's only one point for each. Okay, so it never touches the graph twice, so it is a function. Okay, and our domain for this guy, element of a real number, and that you can see with your x, it's anywhere that's above 0. So anything that's greater or equal to 0. There's no arrow on our graph here that says that it goes into the negative, so that's why it's only the positive numbers. And then our range is y is an element of a real number, as long as it is between 2 and what is that, 5? Yeah. So it's between 2 and 5. We're going to look at B. So you do the same thing, the vertical line test. So you do invisible lines. It only touches the graph once, so it is a function. Our domain for this guy is the same thing as the other one because there's no arrow here that tells us it's going into the negatives. So that means that it has to be greater or equal to 0. And then our range, it's anything that's lower than this point. There's no points up here or anything. There's no graph. So that would be 1, 2, 3, 4, 5. So anything smaller than 5. Y is smaller or equal to 5. Okay, same thing here. So you're doing lines. So you see that it touches the graph twice. So that means it's not. Okay. And I'm not going to bother with the domain and range for these guys. We're just going to say if it's a function or not. I think it's getting a little bit repetitive. So you do your vertical line test again. This doesn't touch twice. So yes, it is a function. I'm going to clear this and we're going to do the other graphs. We're almost done the examples. Oh, that's not what I meant to do. Okay. Okay. So again, do your vertical line. This touches twice, so no, it's not a function. Do your vertical line on this guy. It only touches once, so yes. Okay. We know right away when you see something of this format, it's not a function. Okay. And then this guy looks just like this, to be honest with you. So that is a function. Okay. So I'm going to clear this. You're on your own for independent questions, and good luck. If I can ever get out of here. It won't let me leave. There we go. Okay, bye guys.